Hi guys and welcome to my new video. In this video I will tell you how to handle an episode 2, a topic of chemistry. It's a very important topic called the periodic table. So this is episode 2 out of I don't know how many videos, but this is a very important video, so you better just be very attentive, okay? So so what is the periodic table, and who made it, and for how long? Why is it used for chemistry, and why is it so important? So I've heard, of course, a lot of you have already knew the guy who invented this table. It's called Mendeleev. He's Russian, and he found out the arrangements of the elements through his dream. It's weird, I know. Through his dream, I mean, by some magic, all these elements just arranged in a perfect order. And when he woke up, he wrote it down, so it appears to be somewhat like that. Okay, so of course it takes some time for everyone in the human race to find out. I mean, the scientists to find out more elements. By that time, around 1700 something, there were only about I think 50-60 something elements being discovered. So the table was much less complicated compared to today. Okay, that's about history. Why is it important to know the periodic table? Because you need to know the group, what group belongs to, what group the elements belong to, what period it belongs to, and I'm going to tell it in more details later. Okay. So here is a better resolution of the table. I mean, I draw it. I knew you won't be needing the full table now. So here it is. Okay, welcome back. So here, I just presented you around 20, 22 or 23 something elements. So let's go into the table first, okay? So you can see from the left to the right, the rows are basically the groups. You can see the groups 1A, 2A, group B metals, 3A, 4A, 5A, 6A, 7A, and 8A. So what is the meaning of the group? The group actually tells you how many electrons are there in the outermost shell of an element. Like for example, sodium is in group 1A. So it means that the outermost electron, the furthest away, electrons flying around it, there are only one electron flying around it, at the furthest, the outermost electron shell. Or, for example, chlorine is in group 7. So it means that there are 7 electrons in the outermost shell of the chlorine. Okay, so if you have watched the episode 1, you would probably knew that the electron configuration of the chlorine is, I think, 3s2 and 3p5. So s2 and then 3p5, you have 7. There you go. The outermost shell, the third one, in this case, has 7 electrons. So you see it at 7A. So what is A and B means here? Group A and Group B metals. Group A elements and Group B elements. So Group A means that the electron configuration of these elements contain only s and p orbital. Group B metals, the electron configuration of this element has D and F as well. So it's much more complicated for group B metal. Okay. Right, let's get familiar. So what does the period means? The period tells you how many orbitals are there surrounding the nucleus. Let's say for lithium, for example, period 2, it means that there should probably be 2 shells surrounding the lithium. Let's say here I have a nucleus of lithium, so it has 3 protons. 1, 2, 3, 4, 5, 6. So 3 protons. It's a bit too small, I think. And then you have 2 periods. So the first is 1s. And then you have 2s and then 2p as well. But generally, say the second shell, the 2s and the 2p, is the last one. So that's why it's in period 2, okay? Now, so I would recommend you to remember from element 1 all the way to calcium, which is the 20th. Okay, so let's go slowly. Hydrogen, 1, 1. Helium, 4, 2. Lithium, 6, 3. Beryllium, 9, 4. Boron, 10, 5. Carbon, 12, 6. Nitrogen, 14, 7. Oxygen, 16, 8. Fluorine, 19, 9. Neon, 20, 10. And sodium, 23, 11. Magnesium, 24, 12. Aluminum, if it's British English, it's gonna be aluminium, but American they say aluminum. Aluminum, 27, 13. Silicon, 28, 14. Phosphorus, 31, 15. Sulfur, 32, 16. Chlorine, 35.5, 17. And argon, almost 40, 18. Potassium, 39, 19. And calcium, 40, 20. So basically, I don't ask you to remember all these numbers. Of course, that's nearly impossible for you guys right now. But at least you have to know like what group the element belongs to, because that's going to help you greatly. What group it belongs to. Okay, please try to remember what group these elements belongs to. Okay, so let's do some example, shall we? What group does fluorine belong to? Fluorine is actually 19,9. So if you have that values of 9 protons, you can probably get out the electron configuration. So 1s2, 1s2, and then 2s2, 2p5. So the second shell would probably have 7 electrons. So that's why it's in group 7a, group 7, and 7a because it has s and p only. Okay, let's do another example. Let's talk about magnesium. Magnesium 24, 12. So what group does magnesium belongs to and what period? Okay, from the 12 protons, 12 atomic number, you can get that the magnesium has a configuration like this. 1s2, 2s2, 2p6, so that's 10. And then to get 12, you need 3s2. So 3s2, so the period should be period 3. And it has 2 electrons on its outermost shell, so group 2 metal. And 2a because it has only s or p. Okay, that's 2 examples. I hope it was helpful for you. So let's talk about another aspect of the period table I think everyone should know. is called electronegativity. So what electronegativity is? It's the likelihood of an element to attract electrons to it. So it's like if you have a nucleus, you have an atom, so it will be likely to attract electron to it, just like a superstar attracting fans. It's like that. So the higher the value of electronegativity, the more attractive the atom is. So for example, here you can see fluorine. It has the highest value of 4.0, which means fluorine is a superstar, the super mega superstar of the whole table, because surrounding it, a lot of electrons will be drawn into it. It's like very attractive to electrons. And if you go down here, put potassium and something down below, the values of electronegativity is like 0.2, 0.3 something. Very small, so it's the least attractive. So once again, so what is electronegativity? It's how attractive the atom is to electron around it. The higher the value is, the more attractive the atom is to electrons. And the lower the values, the less attractive. Okay, so in the table it follows this kind of trend. You can start with the bottom left, which is the lowest value of electronegativity. Once you go up, the value increase. And once you go from the left to the right, the values also increase. So you can just say go from bottom left all the way to the top right. It increases. Okay, how can one explain this phenomenon? Okay, so let's look at, for example, in the same period 2, for example, lithium, it has only 3 protons on its core of its nucleus. On its nucleus, while fluorine has 9. Because it has more protons, it also has more electrons as well. And positive and negative attract each other. So of course this one has less compared to this one. So probably the fluorine is going to be much more attractive to electrons. Just think about it this way. If the inner has, say, here I wrote down 7 electrons. Of course it should have 7 protons. It should have 7 electrons surrounding it as well. But let's look at the electron and the proton. Electron is negatively charged and proton is positively charged. So at one moment, this one electrons is going to be attracted to 7 protons at any moment. So it means that it's much more drawn into the center. So it means that the more proton inside the nucleus, the more like electronegative the whole atom is going to be, and vice versa. So it means that if you go in one period from the left to the right, the electronegativity is going to increase. And of course if you go from the right to the left, it decreases. Makes sense. Now, how about in the same group? Why when you go up, the electronegativity increases? Let's look at calcium, for example. It has 4 shells surrounding the nucleus, compared to this one beryllium, only 2 shells. 4 shells, of course, the distance surrounding the nucleus is going to be much further apart compared to beryllium. Because the distance is so far apart, the electrostatic force between the electrons and the protons is going to be very weak. It means that the more shell it has, the less the electronegativity. And if you go up, the electronegativity will increases. Okay, that's some basics. So let's do some example. I would recommend you to remember the electronegativity of about 5 or 6 elements maximum. Because why? They're gonna help you greatly in the organic chemistry and in drawing the structures and everything. So I would recommend you to remember the hydrogen. The value is 2.2. Please write that. Write down 2.2 for hydrogen. Carbon is 2.5. Nitrogen is 3.0. Oxygen is 3.5. Chlorine is 3.2. And of course, the superstar of the periodic table, the fluorine, 4.0. If you want to, you can try to remember sodium, which is 0.7. So 7 of them. Why? Because the C, H, O, and the N are the building blocks of the chemistry, building block of organic chemistry. You would have to use them a lot. Not just that, many elements, many reaction in the book or in the program is also linked with these 4. C, H, N, and O. Besides, the chlorine, you can also see them a lot too, and the sodium, of course. But the fluorine, not that much. It's just like, you have to know that this is the 4.0, maximum in the table. On the table, sorry. Okay. Okay, that's about electronegativity. We'll definitely get back to it soon enough. Okay. Now, I would like to discuss about the next aspect, which is the atomic radius. So what is atomic radius? Radius is a distance between the center of an element, of the atom, to the shell, to the outermost shell. So distance between the center and the outermost shell. So let's say, for example, you have an atom like this. The distance between the center of that and the rear, this distance is called the radius. Okay, thank you guys. Okay, and then why atomic radius matters? Because basically the more shell around it, the bigger the radius. So atomic radius, remember, it's atomic radius, not ionic radius, okay? Because now I'm just talking about a neutral atom, not ions. It's neutral atoms, atomic radius. So what's the trend here? In the same period, if you go from the left to the right, the atomic radius decrease. It just gets smaller, smaller and smaller. How come? Why? Because as you know, the electronegativity, you go from the left to the right, increases, right? It means it's more attractive to the electrons. So the electrons are more squeezed into the center. It's more squeezed into the center. So it means that the radius is going to decrease. Okay, once again, from the left to the right, the electrons is going to be more attracted to the center, so it makes the whole atom smaller and smaller. Just get smaller and smaller because of that. And how about in the same group? Obviously, if you go down, the radius is going to get bigger and bigger because they have many more shells. Okay, so I hope it was helpful for you. Thank you for watching my short video. I hope it was not too long. Thank you, and so see you in episode 3. Bye, see you.